right, gang, STAT1150, still in lesson number one, focusing now on numerical summaries for quantitative variables. What I want to work for you now is demo for video number 5. And so again, keep in mind that I'm creating all of this as you see it. So you're going to see it evolve and develop. But by the time you're taking the course, this will already be established. But anyway, find lesson number 1, demo for V5, video 5. And let's start. There are 3 questions, and I don't think these are going to take very long. Now, the purpose, again, is to introduce you to numerical summaries for quantitative variables. But we're going digging a little deeper in this video and showing you how these measurements are found using my StatCrunch. So what we have is we have listed below the ages of 11 players randomly selected from a roster. Find the mean, median, and mode and mid-range. I don't think we've talked about the mid-range yet, so I'll have to teach you a little bit about that. And resulting statistics are fundamentally different from those calculated from the jersey numbers of the same 11 people. Well, you would kind of think so. So we want to, this is a little confusing to me. So 11 players, so these are the ages. So the jersey numbers, again, this is confusing. So we want the mean, median, and mode for the ages. Okay, so we need to use this data set. All right, so let's go to stat, go to summary stat, go to columns. And I want variable 1. I could rename that if I want, but I'm not going to. So I need the mean, it seemed like the median, and the mode. Now it talks about the mid-range. I don't think there's any place here to find the mid-range. Turns out it's super easy to find. So we'll just go ahead and compute. So looks like the mean is going to be 28.7. The median is 28. And in the mode, there's there are multiple modes. So let's see how we're supposed to handle that. So mean 28.7. The mode is 28. And at mode, so there were multiple modes. So I guess we're supposed to just type that in right here. Now, there's really no way to find the modes, but something you can do to help you identify the mode. If you'll come right here to the drop-down menu and sort your table in descending order, we can see that there are multiple 24s, there are multiple 27s, and there are multiple 29s. So 24, 27, and 29, right? So let's report that. And unless there's a typo, that should work. Okay, find the mid-range. Again, something we haven't talked about yet. The mid-range is just the average of the lowest score and the highest score. So the easiest way to find the mid-range is just to take the highest score, which in this case is 41, plus the lowest score, which in this case is 22. Add those together and divide by 2. So the sum of the two scores is 63. 63 divided by 2 is 31.5. You know, I've been involved in a lot of research over my years. I don't even know how many, a lot. And I have never, ever reported the mid-range. So, but we'll play along since they want us to create that. All right, so how are the resulting statistics fundamentally different from those calculated for the Jersey numbers? The Jersey numbers are data that are, well, those are going to be nominal, but the ages are data at the ratio scale. So the age are meaningful. And again, that comes from the previous video where I demonstrated this stuff. All right, so the mean and security, we want, looks like the mean, we're going to find the mean and the median for the two different samples. So let's open this up in StatCrunch. All right, so again, summary stats column, and we want both of these. And I think they said we want the mean and the median. All right, so I'm just going to write this down. So 1.46 and 1.8, and the median is 1.45 and 1.65. So the first is the mean, second the median. All right. So the median for security is 1.46, and the median for the other companies is 1.8. The median for the two companies looks like 1.45 and 1.65. Now, that's the easy part. They usually come in with some relatively tricky questions. Okay, so here we go. Compare the results. Choose the correct answer from below. Well, what I can see is I can see that the security company mean is lower, and I can see that the security company median is lower. So that may be where we're headed with this. So the mean and the median for the collection performed by the other companies are both lower. Well, that's a false statement. The mean and the median for the security company are both lower than the club. So this is going to be the true statement. Do the limit data listed here show evidence of stealing by the security company's employees? Sample size is not large enough. I don't think that's the case since the security company does not appear to have collected. There's no evidence of security. Since the data is not matched, that's not really relevant. D, since the security company appears to have collected lower revenue than the other companies, which is in both cases by the mean and the median, there appears to be questionable practices going on here according to the data. So I would select that question. All right, gang. The next question deals with 6 celebrities with some of the highest net worths: George Lucas, Spielberg, Oprah Winfrey, etc. So we're switching our focus here in this problem to measures of variability. Specifically, the problem asks us to find the range, the variance, and the standard deviation. So let's grab the data and open it in StatCrunch. Process is pretty straightforward now. Go to Summary Stats, go to Column, select the variable, and select the measurements of interest. All right, so the variance is, that's kind of a, so how many 4s do we have there? So 3, so what, 4 4s? So I'm going to go 3444417. The standard deviation is 1856, and the range is 4550. All right, so range 4550. The variance is 3, and then 1, 2, 3, 4, 1, 7. And the standard deviation is 1856. All right, what do the results tell us about the population of celebrities? Actually, very little, because these aren't a random sample. These are some of the highest net worth. So the answer that I'm looking for is very, very little value. So calculated the measure. Typical, no, not typical. Okay, so B appears of interest because the data are from celebrities with the highest net worth. The measure of variation are not at all typical for other celebrities. Seems reasonable. Okay, this is interesting. Based on the nature of the amounts, what can be inferred about the precision? Because all the amounts end in, so this amount ends in 100, 100, 100, 100, and okay, this one just ends in a 0. So all end in a 0. It appears they are rounded to the nearest, so what, 10 million, I guess? Yeah. And it would make sense to round the results to the nearest $1 million. Yeah, seems reasonable. Kind of a wacky question, but yeah, I think there's not really much explanation there. Just look at the measurements, and because this is rounded to the 950, the rest of them are rounded to the nearest thousands. If this was the nearest thousand, it would be 1,000. So yeah, not really much to say about that. All right, gang, that's it. There were only 3 questions. That's all I got. Take care.